part of this video, we're going to talk a little bit about how we're going to review distance time graphs and how we can convert the information given to us from a distance time graph into a speed time graph. Now we have to remember that a distance time graph gives us information about the displacement of the object, how far away an object is from its reference point, and we can also extract information about slope. So we can know the position of the object, the speed of the object based on the slope, and we also know some information about acceleration. Now in a speed time graph, we know the speed obviously of the object based on the graph. We can get information about the acceleration, but we don't know the position. However, we can extract information from this and convert it into a speed time graph. So let's look at the first one. In this first distance time graph, we can see that the object moved 7 units in a matter of, let's say, seconds. We'll pretend this is seconds here. So in 7 seconds, the object moves 7 units. So we can determine that its speed is 7 over 7, which is 1. So 1 unit over a second. So its speed is 1. So then we can come to our speed time graph, and in the 7 seconds, we can indicate that the object went at a speed of 1. Sorry, this should have been a straight line. So it went at a speed of 1 in 7 seconds. Okay, and this is how we can indicate this. Let me try to make a better line here. Okay, again, we can see that the speed is constant here. It doesn't change, just like we see a straight line here to indicate the speed is constant, and there is no acceleration. Now in this object here, in the second graph, we can see that the object traveled 6 units in 2 seconds. So in this first part of the graph, we can see that the speed is 6 over 2. So we can determine that the speed is 3. So for the first 2 seconds, this object travels a speed of 3 units per second, and it's constant. So we can go here, 3 units for 2 seconds. Now, at the 2-second mark, we can see that the object here was 6 units away and then stayed there for the rest of the time, for the 5 seconds. So for 5 seconds, this object did not move. How will we show this in a speed time graph? Well, we'll show that at the 2-second mark, the object for 5 seconds was not moving. So the object was on, we put a line here on the x-axis to show that the speed was, in fact, 0 for 5 seconds. So this is how we would convert this graph into a speed time graph. Now let's look at this next one. Now here we have a little bit of a difference. Here we have a negative slope. Now we have to remember that a negative slope in a distance time graph does not tell us that the object is decelerating. It simply tells us that the object is moving in the opposite direction. Now, at what speed is this object moving? Well, we have to determine its slope. Here we go from 6 to 2. So it moved 4 units, and it did that in 2 seconds here. So the slope of this object in the first leg of its trip was 2 units per second. So how would we show this in a speed time graph? Well, this is where the negative quadrant comes in. So at -2, and this is -2. Okay, so at -2, we would be down here, and that's for 2 seconds. So for 2 seconds, it was a speed of -2. Again, the negative doesn't mean they're slowing down. It simply means that they're moving in a different direction. Now in the next 2 seconds, the person went from the 2 units to 4 units. So in this leg of the trip, it was 2 units over 2, which is equal to 1. So the speed in the second part was 1. So we're going to go back up here, and that was for 2 seconds. We're going to indicate the 1. Now we can attach it like this. Okay, and in the last leg of this trip, we can see that the person stayed at the 4 unit mark. They stayed there for 3 seconds. There was no motion. Now to show no motion in a speed time graph, we would simply put, like we did before, for 3 seconds, right on the x-axis, and that should be right on the x-axis, by the way. Okay, so this would tell us that the person is not moving, just like it tells us here. Okay, but it's right on the x-axis. Now for this last one, first part of the trip, the person went from 5 units to 7 units, so that's a difference. So the speed here, if we calculate the speed, essentially when I'm calculating the speed, I'm calculating the slope, 2 units, and it did that over a matter of 4 seconds. So the speed is 0.5 units per second. So here we would be somewhere, I guess, somewhere between 0, and that's for 4 seconds. Sorry, it's a little difficult here with this pen, but I'm going to try my best. Four seconds, excellent. This second part of the trip here, he went from 7 to 1, so that's 6 units. And it did that in 2 seconds. And by the way, that was -6 units because we decreased. So it's a speed of -3. So we're down here, and we did that for 2 seconds. We can, oh. Okay, let's start that over. So we said here, let's do this one over. So 0.5 for 4 seconds. Then we were at -3. So let's do this one again. The second leg of the journey here went from 7 to 1. So it was a decrease of -6, -6 over a matter of 2 seconds. So the speed was -3. Now the negative again, I'm going to say it one more time. The negative does not mean that they're slowing down. The negative simply means that they're moving in the opposite direction. Okay, and the last leg of this trip here, again, they're not moving. Okay, this simply shows that there's no motion at all. So we bring it right back to the x-axis and the 0. And this shows us that there's no movement. So a speed of 0.5, then down, moving in an opposite direction at a speed of 3, and then again, there's no motion here. Okay, so how do we go from distance time graphs to speed time graphs? Well, we extract the information about the speed from a distance time graph, or we find the slope, and then we transfer that over onto the speed time graph.